Hi students, how are you? I hope that you are all preparing well for your JEE mains examination 2023. Okay, so to help your preparation, so I am coming before you to explain a previous year JEE mains problem which were asked from the chapter limits, continuity and differentiability. So without wasting your valuable time, so let us start our class. So the first problem is a tangent at x1 comma y1 to the curve y is equal to x cube plus 2x square plus 4 and passes through origin. So that means the tangent is also passes through origin. Then x1 comma y1 value is equal to how much? Okay. So if you draw a diagram, the problem will be looks very nice. Okay. What is that? There is a curve. So it is there is a curve is there. Its equation is y is equal to x cube plus 2x square plus 4. Okay, now right, very clear. At a point, so that means there is a point on this curve, that is x1 comma y1. At a point x1 comma y1, there is a tangent. It is a tangent. This tangent is also passes through origin. Let us call it as a and it call it as b. Also passes through origin. Then is asked to find out x1 y1 value. So if you observe here, x1 y1 lies on the curve y is equal to x cube plus 2x square plus 4. Therefore, we can do the option verification. If you see the option verification, substitute x is equal to 0, 0 here, y is equal to 4. Therefore, option A is the right. And minus 1 comma 5. If you substitute minus 1 here, minus 1. Here 2 plus 4, 2 plus 4, 6, 6 minus 1, 5. 5 and 1 comma 7 satisfies, 2 comma 20 also satisfies. So all the 4 options satisfies this equation. Therefore, there is no elimination process. I tried, is there any point is there which does not lie on the curve? All the point lies on the curve. So in general, in JEE mains examinations, a very little chances are there for this elimination of the options, the technique. Okay, so all 4 points lies on the curve. Now we have to, there is no elimination of the options. Let us start the problem. Then how to tackle this problem? The first thing is we have to solve x and y1. That means we want x1 y1 means we want 2 equations in the x1 y1, right? So first one is x1 y1 lies on the curve. Therefore we have y1 is equal to x1 cube plus 2x1 plus 4, that is equal to equation 1. Immediately we got the equation 1. Then how to find out the second? So we find the slope y1 by x1, that is y2 minus y1 by x2 minus x1. Okay. In another way also we can find out the slope of the tangent by taking the differentiation of that curve, that is equal to dy by dx is equal to 3x square plus 4x. Okay. What is the slope of the tangent? M is equal to 3x1 square plus 4x1. So you have to substitute x1 y1 in this dy by dx. Okay now. But these two are equal. This is also slope of the tangent. This is also slope of the tangent. Therefore, 3x1 square plus 4x1 is equal to y1 by x1. Okay. So take cross multiplication, 3x1 cube plus 4x1 square is equal to y1. Call it as second equation. Okay now. From 1 and 2. From 1 and 2, there are 2 equations we got. We can easily solve x1 and y1 values. So here y1 is equal to, this also y1 is equal to. So we can equate x1 quantities, that is equal to x1 cube plus 2x1 plus 4 is equal to 3x1 cube plus 4x1 square. Okay now, right. Actually speaking, this is a cubic equation. You have to solve it. But by observation, you can easily tell x1 value. You can easily tell x1 value. Why? Because here you see here 1, 2, 3, 4. There are 4 options are there. So 0, minus 1, 1, 2. So your x1 value either 0 or minus 1 or 1 or 2. Easily when you can guess x1 is equal to 1. Check here. 1 cube 1 plus 2 plus 4. 1 plus 2 plus 4 is equal to how much? 7. 3 plus 4, 7. 7 is equal to 7. Okay, now easily you can guess. Why? Because already options are there, right? So if x1 is equal to 4, automatically y1 is equal to 7. Substitute here. X1 value substitute here. So 3 plus 4, 7. So therefore, what is your point? 1 comma 7. Very easy problem. So this was asked in 2022. Okay. So find the slope of the tangent in general method y2 minus y1 by x2 minus x1, and in the differentiation process both you equate it, we will get the answer. Okay na? I hope that you understand this solution. Let us go for next problem. Welcome to second problem. If f of x is equal to x cube plus x minus 5 and f of g of x is equal to x, it is a composite function, then g dash of 63 is equal to how much? He is asking. Very nice problem. First, by seeing this problem as it is, if you see this relation, that is f of g of x is equal to x, f of g of x is equal to x, this is nothing but g of x is equal to f inverse of x. G of x is equal to f inverse of x, same as g inverse of x is equal to f of x. That means both f of x and g of x are inverse of each other. F and g are inverse functions of each other. This is the first thing you remember. Whenever it is given f of g of x is equal to x, it is given. So g of x is equal to f inverse of x. Take inverse on both sides. Of course, we have to consider that both f of x and g of x are bijections. Okay na? Right. Therefore, g inverse of x is equal to f of x. Okay. Therefore, f and g are inverse functions of each other. Now, he is asking g dash of 63 is equal to how much? First, what is the relation given? So, f of g of x is equal to x. Now, take differentiation on both sides, that is f dash of x, g of x into g dash of x is equal to 1. We want g dash of x. Of course, afterwards in place of x, I will substitute 63. So, this g dash of x is equal to 1 by f dash of g of x. Okay now? I want g dash of 63. That means g dash of 63 is equal to 1 by f dash of g of 63. Right. What is g of 63? I already told. So, this is a f function and it is g function. So, f and it is g, both are inverse functions of each other. G of 63 means what? That means here it is for what value you should get 63. For what value of this value you have to get 63. G of 63 is, that is only low. If it is a function, your number, here you should get 63. Okay, right. F of which value will be 63? F of which value will be 63? See here, f of 4, trial and error. F of 4 is substitute here. What is f of 4 here? F of 4 is equal to 4 cube. 64 plus 4 minus 5. So, 64 plus 4, 68, 68 minus 5, 63 will be there. That means here it will be 4. Okay now? So, f of 4 is equal to 63. Therefore, g of 63 is equal to how much? 4. Otherwise, I can, it will be better if you write down it here. F of 4 is equal to 63. F of 4 is equal to 63. Therefore, g of 3 is equal to how much? 4. G of 3 is equal to 4. Understand this? Why? Because both are inverse functions of each other. Both are inverse functions of each other. If f of 4 is equal to 63, f of 4 is equal to 63, then f of 4 is equal to g inverse of x. That is g of 63 is equal to 4. G of 63 is equal to 4. Therefore, so this is equal to 1 by f dash of 63 value is, g of 63 value is 4. Now, what is f dash of 4? What is f dash of 4? So, what is f dash of 4 means? So, here wherever f dash of is x is there, wherever f dash of 4 is there. First substitute f dash of x, find f dash of x. This is equal to 3x square plus 1. So f dash of 4 is equal to 3 into 4 square 16 plus 1, that is equal to 1 by 49. So this is equal to 1 by f dash of 40. So this is 49. So this is 49. So this is 49. So g dash of 63 value is 49. So of course these are not the options. So therefore g dash of 63 is equal to 1 by 49 is your answer. Okay, now 1 by 49 will be your answer. From this problem, what the thing that you have to remember is, whenever f of g of x is equal to given, then f and g are inverse functions of each other. That is the first point you have to remember. So if you remember that point, the problem will be very, very easy. Okay, now I hope that you understand this solution. So let us go for next problem. Welcome to third problem. The third problem is, if limit n tends to infinity under square root of n square minus n plus 1 plus n alpha plus beta is equal to 0, then the value of 8 times alpha plus beta is equal to how much? Sorry, it is not 0. 8 times alpha plus beta value is equal to how much? Right. That means we have to find out alpha value and beta value. Okay. Right. Then how to proceed this problem? Right. Remember this here, n tends to infinity means 1 by n square, 1 by n cube, all tends to 0. That everybody knows. Right. First here, limit n tends to infinity. Of course, it is plus infinity. Let us take the here n common outside. If you take n common outside, this is equal to, that is n square common outside. Sorry, n square take common outside, 1 minus 1 by n plus 1 by n square plus n alpha plus beta is equal to 0. You may ask one doubt, sir, square root of n square is equal to modulus of n. No, sir, yes, what your argument is right, modulus of n only, but here n tends to plus infinity. So n tends to plus infinity means n takes all positive values. N takes all positive values means modulus of n is n. Okay, right. So this implies limit n tends to infinity, n into, this is 1 minus n plus 1 by n square whole power 1 by 2 plus n alpha plus beta is equal to 0. Square root means whole power 1 by 2. So actually speaking, now you have to expand this. We know that trinomial rational expansion, binomial expansions, rational expansion, there we will get the expansion a plus b whole to the power of a plus b whole power p by q forms. Expansions, you know that. So of course here 1 plus x whole to the power of p by q expansion, binomial expansions you get. There we will avoid the higher degree terms. Here we will avoid the higher degree terms. So here we will get limit n tends to infinity n into, so this is 1 minus 1 by 2n plus 1 by 2n square plus n alpha plus beta is equal to 0. Understand this? So what will be here first term, that is 1 plus p by q into x. Okay. Next term will be p minus 1 into q square. Next one p minus, like that it will go on. No? So remaining terms I will avoid. So only 2 terms only I wrote. So these are the terms. Next one. So this implies limit n tends to infinity. So take n inside the bracket. You will get n minus 1 by 2 plus 1 by 2n plus n alpha plus beta is equal to 0. Okay, now, right, as n tends to infinity, 1 by n tends to 0. So you avoid this, that is a n value, avoid 1 by 2n is 0, n plus nl. So that is a, you can take the n common outside. So this implies limit n tends to infinity, that is equal to 1 plus alpha into n plus beta minus 1 by 2 is equal to 0. Okay, now n plus n alpha, take n common outside, 1 plus alpha, this is beta minus 1 by 2 is equal to 0. Now this limit exists. This limit exists means what? Here 1 plus alpha value should be equal to 0. This 1 plus alpha value should be equal to 0. And this beta value should be equal to 1 by 2. Then only this limit will become 0. Right or wrong? So here 1 plus alpha, if it is 1 plus alpha is 0, 0 into, as n tends to infinity means finite value only, finite value only. So 0 into finite value 0. If beta is 1 by 2 constant, then 1 by 2 minus 1 by 2, it will become 0. Therefore, 1 plus alpha is equal to 0. Therefore, alpha is equal to minus 1. Beta is equal to 1 by 2. Understand? Therefore, what is alpha plus beta? 8 into alpha plus beta is equal to minus 1 by 2. So, your answer is minus 4 will be your correct answer. So, here you have to apply the logic here. N tends to infinity. So, its answer is getting 0. That means n tends to infinity means it is a finite value only. It is getting not a undefined term, it is getting finite value. So, this you should not get this. That means 1 plus alpha value should be equal to 0. If it is beta is 1 by 2, 1 by 2 minus 1 by 2, it will become 0. So, you know alpha value and beta value and substitute there, you will get the answer minus 4. So, the thing is here very careful. So, from this step, if you are able to write down, the problem will be very easy. Okay. I hope that you understand this solution. Let us go for next problem. Welcome to fourth problem. Here the fourth problem is d square x by dy square is equal to. So, see the options here, confusing. By seeing the options only, everybody will get afraid. So, what is this getting tension? What is this, all these things? Confusion. First option is minus d square y by dx square into dy by dx whole power minus 3. Like that, options are k. Okay, now that means how to express this expression in terms of in another form. In another form, how to express this. Okay. If you know the fundamental definitions, that is in the differentiation with respect to x and with respect to y and higher order differentiation properties, then the problem will be a very easy one. So, let us see this problem. So, first one is d square x by dy square. Then what is this meaning there? First of all, this is a second order derivative, that is means a differentiation of x with respect to y 2 times, right. So, this is nothing but d by dy of dx by dy. Okay, na? So, this is d square y by dy square. Understand this. See here, this is with respect to y you are doing, this is dx by dy. Now, I will do one thing, this also I will make it into x with respect to x. That means d by dx of, I am writing x here, dx by dy into dx by dy, I have to write down dx by dy. So, why? Because we have one property, that is equal to dy by dx is equal to dy by some dt into dt by some dx. You can do it like this. We can write it like this. Okay, now, right. That means dt same. So, therefore, dy by dx. So, here also dx same. dx same. Therefore, you will get d by dy of this quantity, right. So, this is equal to d by dx of, this is 1 by dy by dx. This is a 1 by dy by dx. That means d by dx of 1 by, that is with respect to y you have to do, into this is 1 by dy by dx. Okay, now, right. Now, what is the derivative of this 1 by dy by dx function? That means here also with respect to x, this also you have to respect to x, you have to do it. Okay, na? So, this is 1 by x. 1 by x derivative minus 1 by x square into again dy by dx derivative, that is dy by dx, that means d square y by dx square into 1 by dy by dx. Okay, now. So, this is dy by dx whole square, this is dy by dx whole, that is equal to minus 1 by dy by dx whole cube into d square y by dx square. This implies minus d square y by dx square into dy by dx whole power minus 3. Option A is your right answer. Very nice problem this is. That means you have to know the fundamental definitions of first order, second order derivatives and their concepts. Okay, na? So first of all, this is a by definition I wrote. So here with respect to y it is there. So dx I made it as. I want to differentiate this, but here with respect to x, here it is with respect to y is there. That's why 1 by dy by dx. This is also one of the problem. This is also 1 by dy by dx I wrote. So this is 1 by x derivative minus 1 by x square. Again dy by dx derivative means d square y by dx square. Derivative of dy by dx is d square y by dx square. That afterwards I simplified this. Okay na? So this was asked in 2011. So such type of problems are also giving. So be careful about this type of problems. Okay. So I hope that you understand this solution. So let us go for next problem. Welcome to this problem. So the problem is, if x square plus y square is equal to 1, then which of these differential equation will satisfy? So it was asked in very long back 2008, very easy problem. So let us start the solution. Okay. So here if you see all this y double dash is also, this means higher order derivatives. That means you have to differentiate the given function 2 times. Let us see what happens. So here the problem is x square plus y square is equal to 1. So now differentiating with respect to x on both sides. X square derivative 2x, y square derivative 2y, and y dash is equal to 0. 1 derivative 0. So here 2 cancel, x plus y into y dash is equal to 0. Again differentiate. Why? Because here you have to eliminate x. Why? Because there is no x here. That's why eliminate x to that means you have to derive. X derivative 1 plus y into y double dash plus y dash du into v formula. Y as it is, y dash derivative y double dash. Here y dash into y derivative, y dash is equal to 0. Therefore, y dash whole square plus y double dash into y plus 1 is equal to 0. So it is clearly option B will be the right answer. Y into y double dash plus y dash whole square plus 1 is equal to 0. Okay na? Right. So I hope that you understand this solution. Very easy problem. Okay. So such type of problems are also may ask in your JEE mains examination. Okay. So I hope that you enjoyed today's class with some more problems and concepts, and tomorrow's class I will stand before you. Until then, all the best.